Mark your own. Here we go. So the written section is what we're marking. This is our practice quiz. It says, for each of the functions below, state the number of x-intercepts, the y-intercept, the behavior. Okay, a bunch of stuff. First of all, what type of graphs are these? Every one of these is an exponential graph. How can I tell? Where is the x? Okay, that's one way I can tell. There's a second way I can tell as well. There's another thing that I need. So first of all, the x has to be an exponent. Give me a second here. I need to pause the video. So you ready? We're back. Pay attention, especially if you didn't do this. Kayvon, don't talk. I'm in a grumpy mood. Okay? Thank you. Every exponential function looks something like this. Y equals some number times b to the x. So to show its times, we often put that in brackets. But there was another condition. We said not only does the x have to be an exponent, we said that b has to be positive. It can be a fraction, it can be a decimal, but it's got to be positive. If the base isn't positive, you get weird stuff happening. You do not get what every single exponential graph looks like. What does every single exponential graph look like, Justin, my friend? Like that or like, okay? But that only works if the base is a positive, non-zero number. Oh, and it also couldn't be a 1. Because 1 doesn't behave like other numbers. What's 1 to the 5th power? 1. What's 1 to the 6th power? Still 1. What's 1 to the 7th power? Still 1. So we said, can't be 1. All right. What do they all look like? Well, every single exponential graph, Justin, looks like what? This, or like that. Now, well, that first one's a little yucky because it starts to curl up. That wasn't what I wanted. Kind of like that. Okay, they all look like this. This is when b is bigger than 1, the base. This is when b is less than 1, but also bigger than 0, because I said the base has to be positive. Okay? As an example, this would be y equals 0.3 to the x, maybe, or I need more numbers. This could be something like y equals 5 to the x, or something like that. So now that I know that, let's see if I can answer this. Number of x-intercepts for every one of these, none. So those of you that didn't do this, throwing away marks, I think. Y-intercept. Now the y-intercept is always a, the number in front of the b, the coefficient. So the y-intercept is 12. Well, 0, 12 is 0, 0.11 is 0, 1, because that's the number that's sitting right there. 0, 0.75. Half mark for each of these, by the way. End behavior for all of these, they start in quadrant 1 and they go to quadrant 2. Or you could say they start in quadrant 2 and they go to quadrant 1. I'm not going to be that fussy. Domain. Every one of these has a domain of all real numbers. You can put that for each one of those. Range. Every single one of these has a range of everything above but not touching 0. Okay? Is that okay, Brooke? You had your pencil up like a question. No? Okay? So those 3 columns are kind of similar. Increasing or decreasing. Sean, it depends on the base. Decreasing. Decreasing. Increasing. Increasing. Now, you could type these into your graphing calculator and actually graph these. I have a feeling if you do that, because it's going to take long, you might not finish the test in time. I don't know. So this section is out of 1, 2, 3, 4, 5, 6 by 4. Half mark each. This is out of 12. Can you give yourself a score, an honest score, please, out of 12 on this page, and then turn the page. Match each function to its corresponding graph. Number 2, what I'm really looking at, since I noticed that these graphs are growth and decay, this is a growth function. This has got to be graph A. This is, graph 1. This has got to be graph 2. Why? It's all about the base. Also, I noticed they both have the same y-intercept. They'll both have a y-intercept of 3, so that didn't help me at all. Since 2005, a group has been tracking the deer population near the town of Hudson Bay, Saskatchewan. Construct a scatter plot and draw a sketch of it here. Okay, so now we're going to actually enter some data. Again, a number of you didn't know how to do this on the last test. You need to know how to use your graphing calculator. You also need to bring your graphing calculator on Monday. I will be very reluctant to loan you one. Showing up prepared for a test is inexcusable in my mind. So we have 1, 2, 3, 4, 5, 6, 7, 217, 236, 259, 281, 306, 335, 359. I'm going to graph. Hey, that does look like just an exponential graph. So it says construct a scatter plot and draw it here. Something like that. I don't think this one should be worth 2 marks. I probably won't make it worth 2 marks on the test, but for now that's okay. 1, 2, 3, 4, 5, 6. Probably need 1 more point. Probably right there-ish. What I'm more interested in is finding the exponential equation, the exponential regression function that models the data, the exponential regression function. So I'm going to go calculate exponential. Now again, my calculator only allows me to go base e. So this is one possibility. If you use the base e feature, you'll have a graph that looks like this. Y equals, and then we'll do your answer, 199.83 e on mine, e to the bx 0.0849x point. What do you folks have on yours? You have y equals, you'll still have 199.83, but you can have a different base all to the x. What do you folks have for your base? 1.09? I would take that. Now the only thing is I don't like using x's and y's. On the y-axis is, or sorry, on the x-axis is t time. And how about p for population? I would probably write it this way. P equals 199.83 e to the 0.0849x, or P equals 199.83, 1.09 to the, why did I go x, Mr. Dueck? I said I wanted to use a t there, sheesh. T and t. For 2 marks, I would probably give you 1 mark for that, 1 mark for that, but I would take a half mark off if you forgot to put the variables in. On the last test, I saw a lot of kids, they just wrote down the coefficients. You have to actually put the a there, and you have to put the x and the e in my example, or you have to put your base there to the power of x. You have to actually include the x's and the y's. Okay? C says, assuming the same growth rate, predict the deer population. Oh, this page, I guess, is out of 1, 2, 3, 4. Out of 4. And for some reason, I have an out of 6 there. It's because I changed the spacing. C says, assuming the same growth rate, predict the deer population 10 years after that. So now I'm going to copy my equation, and I'm going to go to the graph menu. I'm going to activate that equation. Ha! I remembered finally. 10 years, is that an x value or is that a y value? 10 years, is that an x value or is that a y value? That's an x value. Okay, so what I want to do then is I want to go draw it. There we go. G-solve. I want to do a y calculation given an x value. I run into a problem. Why do I run into a problem? I have a feeling my graph doesn't go over far enough to fit x equals 10 on there. I think change my view window. Yeah, my maximum x is 8. You know what? I'm going to go to 12, and that'll fit a 10 on there quite nicely. Now if I draw, looks like that. G-solve. Y calculation when x equals 10. It says y equals, looks like the population is going to be 467. Did it give me what? Okay, no, So I'll say 467 because, yeah. Sorry? Okay, so again, they've given me this. Is that an X value or a Y value? Look at your chart. 10 years. Is that X or Y? Okay, so what we have to do then is we're going to we copy the equation. Yes? We're going to plug in X equals 10. Now initially, and the easiest way to do that is to go look up, just watch, is to go G-solve, find a Y calculation when X equals 10, because it wants us to find a Y if they gave us an X. The problem when I did it the first time was my view window only went to 8. So when I went draw, when I went G-solve, when I went Y calculation and I typed in 8, I got an, sorry, when I went Y calculation and I typed in 10, I got an error. My graph wasn't over far enough. Okay? So then I said, all right, let's change my view window. So I went to 12 just to make sure that, look up, I went to 12 just to make sure the 10 would fit. Exit, draw, G-solve, Y calculation, and it says that after 10 years, the Y population is that. Is that okay? I hope. Now, does it make sense to say that there are 467.1 deer? Can you have 0.1 of a deer? I think here they don't need to tell me what to round off to. I'm going to say 467, 1 mark. Okay? 467. Colin, part D says, in which year would you expect the population to have doubled? What are they asking me to find in part D, Colin? A year or a population? A year. They're asking me to find an X value. That means they gave me a Y value. Now, population doubled. What was our initial population? So what they've really said is let the population be 217 times 2. You know what? 434. That's the population have doubled. Okay? So they've said, okay, what year will the population have doubled? Here you go. Doubled would mean take your initial and Kayvon, double it. So that's going to be G-solve. This time I'm going to do an X calculation. My population is 434. When does this deer population double? Apparently about 9.1 years in. Yeah. Okay, hang on. First of all, the correct answer is 9.1, approximately 9.1 years. So you doubled this value here. Okay, so a little strange. I'll give you a half mark. Now, if you doubled that one there, 467 times 2 is 800, is 920, is 934. I don't even know if that's going to fit on my graph. No. I'm going to have to go to 1,000. And I'm going to have to probably add a few years. G-solve. So if you type in Kayvon, did you get 18.1? Yep. Okay, I'll give you a half mark for that. You did it wrong. I did the work right. Yeah. So what? Okay. So these are some of the questions. I guarantee on the written section of your test, I'm going to give you some type of data. It's going to be an exponential growth or decay. And then I'm either going to give you an X value, say find the Y value, or give you a Y value, say find the X value, and ask you to do something with it. Okay? By the way, just because I'm a nerd, what decimal is after the 1 here? Read it to me. Point what? What comes after the 1? This is about a 9% growth. The decimal actually tells you your percentage growth. Okay? It's around 9% growth every year. In the base E equation, this decimal tells you the approximate percentage growth. This is saying around 8.5%. Anyways, this population is growing at about 9% a year. Log graphs. Now, Log graphs look like this, or they look like that. All log graphs have the equation a log base b of x. Shh. Here, b is bigger than 1. Here, b is less than 1. So let's see. X-intercepts. First of all, y-intercepts. None. No. So notice for an exponential, no x-intercepts. For a log graph, no y-intercepts. Number of x-intercepts, number of y-intercepts, 0. What's the x-intercept? Well, for the x-intercept, it's going to be, doing a y-intercept, 1, 0, 1, 0, 1, 0, 1, 0. They all go through 1, 0. You can change that, but you got to muck around with it a little bit. End behavior. These all go from quadrant 4 to quadrant 1, or from quadrant 1 to quadrant 4. So all of these go from 1 to 4, or from 4 to 1. Domain for all of these, it's everything to the right of x. It's that, but not touching 0. Range, it's everything up and everything down. The range is all reals. Increasing or decreasing, it depends upon the log base. It depends upon either the log base or whether it's negative or positive. So the other way to make this decreasing is to have A be negative. This will decrease, this will decrease, this will increase, this will increase. That's right, we're not changing the bases with you guys this year. So it's going to be increasing, decreasing, increasing, decreasing. Let's confirm that. If you really want to, we can graph this. Let's delete what we have here. 3 log x. Let's go view window, view standard. First go. There you go. Increasing looks like that. Okay. Again, half mark for each of these. This is 4 by 6. So this is out of 12. And we have a question out of 1, another question out of 1. So this page is actually out of 14. Number 5 says, match each function with its corresponding graph. We have some logarithmic, we have some exponentials. Okay? I think these two are the exponentials, aren't they? Because just in every exponential graph looks like what? Or like, okay? So this is either C or D, and this is either C or D. How can I figure out which one's which? First thing I check is the base. That's a 3. That's a fraction less than 1. D is going to be a decay graph. C is going to be a growth graph. So the first graph is graph C. Second graph is graph D. Let's put that here. Graph 1, graph 2. What about logs? One of these is going to be getting bigger, one of these is going to be getting smaller, and what affects that, much like the parabola, is the negative. The negative in front, like the parabola, flips the graph. So this is getting bigger, this is going to be positive, this is going to be graph B, and negative flips it over, this is going to be graph 4, graph A. This page is out of, I guess, just 4. I could only fit 4 of those on the page. This last one you need to pay important attention to, because you're going to, if we do this, initially we're going to get a calculator error, and we need to interpret it, okay? So first of all, it starts off with some science nerd talk. It says the euphotic zone is the upper 200-meter layer in an ocean. Okay, whatever. Very little sunlight penetrates deeper than 200 meters. I've watched nature films. As submarines get deeper, what happens to the light in the water? It gets darker. It turns out the rate at which it gets darker is a logarithmic curve. Okay? As a result, 70% of all photosynthesis occurs in the euphotic zone. Okay, you know what? I got to be honest. Every bit of this is interesting, but I'm not going to use any of it. Pause. As I was saying, folks, look up. Okay? As I was saying, this is just all science nerd talk. Here's what I notice. They've given me a table of data, and they've said, do a logarithmic regression function. They want me to find the logarithmic regression function. So Christina, here's what I did. I said, okay, let's go to my stat menu. Let's delete any data that I have here. And I started out and I did this wrong. I went, well, usually the first column is the x column. So I said 0, 20, 40, 60, 80, 100. And then I said, okay, it's 100, 55.37, 30.57, 17.08, 9.74, 5.76. I said, excellent. This looks good. I hit graph. The first thing I noticed is that doesn't look like a log graph. What does that look like, Justin? What does this look like? Exponential. So I started to go a little bit, but okay, I went calc. I said, all right, let's find the logarithmic equation that goes with that. And when I did that, I got that. Now, here's what that means. My calculator is saying, I'm sorry, based on the data that you've given me, I cannot find a logarithmic equation that fits this. What it really means is I've got the x and y in the wrong column. I need to make this the y column and this the x column. Okay? Is that okay? I could see based on the way the data was going, because I've seen how the numbers work, but you know what? The quick and easy way, because it takes, what, 15 seconds to enter the data, is, your calculator lets you know, okay? So, you have two options. You can retype it, putting the x and the y in those places, and that's probably the quickest. There is a way you can actually, using this set the table, you can make list 1 y and list 2 x, but then you have to remember that you've changed it on your graphing calculator and go back and change it later. So I showed some kids how to do that. I'm just going to say, you know what? Very quickly, I'm going to delete all. I'm going to put this in the, so 0, 20, 40, 60, 80, 100. That's going to be in my y column. 100, 5.37, 30.57. I mean, Roy, it's not going to be longer than 60 seconds of delay. So there are ways to tell, but most of them to tell take as long as 60 seconds to do the math to find out ahead of time, in which case I'm kind of pragmatic and I'm going to say, well, do it wrong, find out it doesn't work, and redo it. Okay? Now, if I go graph, now that still kind of looks like what we had, but let's see. Calc. Now it gave me a logarithmic equation. Now remember, the format for all of you is base ln, the natural log, b in front, a coefficient, and a plus right there. So the equation, the logarithmic regression equation, is y equals 159.86 plus, there's a plus, b, negative 34.867, negative 34.867, natural log of x. Except, let's see, I'm going to use P for penetration of sunlight, and I'm going to use D for depth. And I'm really doing that on purpose here because my column has been switched around. I don't want to accidentally get confused. Here's my equation. 2 marks. Again, 1 mark for that, 1 mark for that. But if you forgot to put the variables in, take a half mark off. By the way, the plus negative is redundant. You could just go subtract. I know my audience. Yeah. I'll live with x and y. Here's my only concern, Kayvon. Do you notice how I've got the y here and the x here? I'm worried I'm going to get them mixed up, so I'm going to be be less likely to get it mixed up by going P, D, D. Okay? I'm not going to take marks off, but it's sloppy, and you might have done the next part wrong. Let's find out. It says, determine the amount of sunlight that penetrates to a depth of 200 meters. This is a depth, right? So they want me to find a p-value. Or in my equation, they want me to find an x value given a y value. That's why I did that, because that would be hard to decipher otherwise. So I'm going to copy this equation, enter. Hopefully it's there. Hey, there it is. I'm going to turn the graph on. Draw. Now, they've given me a y value of 200, so I'm going to go gsolve. They want me to find an x value when a y value is 200, and I get a really small answer. I get 0.316%, almost no light. Basically, at 200 meters, it's almost pitch black. 1 mark. Okay? On this page, you can give yourself a score out of, 3. That one worked. And if you'd be so kind as to give yourself a score, an honest score, right here at the top out of 39, please. So, folks, a little advice. First of all, this being my first year doing this course, I'm actually doing something I hate. I'm using a test data bank to create the tests. So if you're wondering, the multiple choice section will be fairly similar to these types of questions. And the written section is going to be fairly similar to this. And that's why those of you that didn't do the quiz, this time I didn't make you wait outside and try this because that didn't work well on the last one. I'm hoping you learned from your mistakes, or you followed along, or you filled it in as we went and said, okay, I'm getting the hang of this. Some people have had some questions. Roy, you got a question for the multiple choice. I'm going to guess it's either going to be number 11 or number 12 or number 13 or number 14. Okay. Glad you asked. I like these questions. I like these questions. I like these questions. Okay? So maybe you all want to look at number 12 and or 13 and or 14. Okay? And this comes from the way we defined a log. And Roy, this isn't totally your fault. The textbook, in my mind, in my opinion, has done a terrible job of actually telling you what a log is. And next year, I'll build a couple of extra lessons in explaining what a logarithm really is. But for now, if you guys, thank you. If you guys, first of all, stay on this page, I'm going to go to the log lesson, and I want to show you what we said. We said, if you know this, you know that. Sorry, let me try that again. That's not what I wanted to circle. Circled the wrong thing, Mr. Dueck. Nice one. This line here. If you know this, you also know that. If you know the log of a base of a number equals something, you also know that the base to the something equals what's inside the log. So look at that for a second. See if you can now figure out the pattern. So what did number 12 say? Go look at number 12. Says which correctly, so this is y equals ln of 20. Okay, let's go back. Well, let's write it right here, Mr. Dueck. Y equals ln of 20. Now remember, this is the same as the log base e of 20. That's what natural log means. Ln is base e. I can write this as an exponent. And I can write this as an exponent as base. Now, the nice thing is we call this the base, and in an exponent, this is the base. To that equals what's inside the log. The pattern is this to the power of that equals what's inside the log. Let me do the previous one. So this is, remember, a generic log is base 10. This is going to be 10 to that equals what's inside the log. Okay, that's the pattern. Or if I go in the opposite direction, if you give me this, what's the base of this exponent? It's meant to be really obvious. What's the base of the exponent? 10. It's going to be a log base 10 equals 7 of x. That's the pattern. Look at it again. That to the power of the other side of the equal sign equals what's inside the log. That to the 7 equals that. That's the equation. If you know one, you know the other. This is the pattern. The textbook hasn't done a great job now. I've left one of these on your test, but not 4 of them. Okay? Because I don't think the textbook has done a good job of emphasizing it. So this one here, e to the x equals 7. Is that a hand up? Yeah.
So for 13, what would the answer be?
For 13, the log, so we said that when you that's not what I wanted. We said that when you just see a plain old log, that is base 10. So C. C. And again, really, I'm not a big fan of the way this unit has been set up. Next year, I'll spend like an extra week and a half and actually explain what logs are. I think just jumping in like this is not very effective. Some of you that have been in pre-calc in previous years have seen some logarithms. They're both simpler and more complicated than what we've done here, and far more useful. This next one then is going to be log base e of 7 equals x, except log base e is typically written as our friend ln. So that would be A, C, hopefully that matches the answers in the back, to e to the y equals 20, B, and 10 to the y equals 50, B. Okay. Any other questions from the multiple choice?